Thank you. All right. Welcome, everybody. Before we get started, I have to cover the obligatory product statement. Of course, we love to talk about forward-looking things at times. It makes it fun, as Nick says, but we want you to be responsible and keep that in mind that some of the statements we do make, some of the features we talk about are forward-looking in nature. So please be responsible with that information in your decision-making process. All right. Thanks, everybody, for joining today. I am really excited to kick off this month's Developer Deep Dive call and to spend some time today with the team, really looking at something that's becoming increasingly important for anyone building on our platform, how we think about API usage as part of our overall architecture and design. I want to set the stage a little bit for this topic today. As developers, all of us are used to balancing multiple dimensions when we architect and build apps and integrations. We think about performance, we think about scalability, we think about maintainability, simplicity of our designs, we look at the user experience, data integrity, security, and more. We're never just optimizing for any single metric at one time. We're constantly trading off between them to get to really the ultimate balanced design that our real world solutions live in. What we want to do today is talk about one more dimension in that familiar balancing act for developers, API usage. Not as a singular one thing that matters most, and certainly not as something that should send you back to rewrite all of your existing apps, but just one more signal for you to pay attention to as you design evolve what you build. The next question would be, why talk about this now? Well, to be quite frank, the platform's evolving, and so is the way that we think about the consumption of our apps and integrations on that platform. Over time, and in time for all of you as customers, concepts like flex credits, platform entitlements will all become part of your vocabulary and considerations when you use the platform. Now, we're not going to get into pricing mechanics today. We're not going to talk about the commercial side of things. It's not what this audience is here for. You're, after all, developers. What the session is going to be about is the engineering side of that evolution. And so we want to cover how our design choices translate into API behavior in the real world for us. We want to talk about how often our apps and integrations are calling into the platform. We want to think about the patterns that naturally lead to higher or lower API consumption. We want to talk about opportunities to get free wins, easy wins, and no-brainers for both performance and usage at the same time. And so we really just want to gently bring the topic of API usage into the set of metrics that you instinctively and inherently think about when you're designing and building on our platform. Right alongside all of the classic ones that you've already been considering, right? Throughput, latency, reliability, maintainability, scalability, whatever you want to term it. Without creating any kind of anxiety for you that your primary job is to optimize for any single metric, API cost included, right? It's not. Your job is to be a developer, right? To solve real world problems for your users in robust, scalable ways. We just want to equip you with some mental models and some patterns so that when you have 2 or 3 or more design choices on the table, you can also factor in how they behave from an API perspective. And so again, what today is and what today isn't, right? Today's session, excuse me, is intentionally focused on what I mentioned before, no-brainers, easy wins. We want you to walk out of this session kind of feeling like these are practical things that you as a developer can take to your work and start doing right away. It's also the first of a series of presentations that we'll do through future deep dives. In those future deep dives, we'll start to go into maybe some more advanced topics in this space. We'll cover maybe more advanced optimization techniques that require significantly more effort than what we'll talk about today. We'll talk about trade-offs when you have different levers that you can pull, right, that have impacts. Maybe it's not the most performant in one metric or the most optimized within one metric, but you need to decide what balance you want to strike between those different metrics. And of course, eventually we'll want to talk about the analytical side of this. How do you kind of analyze how your apps are performing and hitting these different metrics? And how can you kind of focus on what you need to focus on to tune those apps or those integrations? Those later sessions will obviously be a lot more involved and may touch on some of these changes with more impact, right? But today's is about building a shared foundation at the most basic level and introducing core vocabulary and core concepts that we can all take and start from the same page as we get into those more advanced topics. So with all of that framing in mind, let's jump into our agenda. Before I do that, for those that don't know me, I'm Dan Pesahowski. I lead our developer relations engineering team. I'm joined by my colleagues here, Merrick, Jared, and Todd, who are all going to be talking to you today about the various topics that we plan to present. That said, here's our agenda. So we're going to kick off with, of course, our best practice of the month, something that we like to call out on every call. We're going to move into something that we learned to share with you that we think is impactful to you as a developer on our platform. And then we're going to get into some light developer program updates, including a reminder that we've got DevCon coming up just about a month away, right? We'll plug it as much as we can. And then we're going to move into the meat of the topic today. Eric's going to talk to you about Orchestrate and specifically some scheduling and looping considerations. And then Jared and Todd are going to wrap us up with talking about the Extend side of the house. They're going to go through some quick wins, talk a little bit about deferred endpoints and the impacts there, and the usage of flow variables throughout your applications as well. So let's get right into it. Let's talk about the best practice of the month. It's a very fundamental best practice, but it's good to think about and it's good to bring ourselves back to at a foundational level, right? And it is to remember that we're always designing for the real world. This starts with thinking, go back, misclick. All right, this starts with thinking and rooting yourself in reality, starting with your end users and your real world scenarios, right? Who is going to use this application? Who's going to use this integration? From where are they going to enter it? How is it going to be triggered and launched? What's the start point for that? What does that real actual workflow look like? It's easy to get lost in the unit test and lose track of what is actually going to happen when this thing is sitting in production, right? We as developers quite often just want to get to done, right? And code through and cover our requirements, execute those unit tests appropriately and hand it off to QA. But the reality is we need to be thinking about those real world scenarios. Once we do that and we root ourselves in those real users, those real production scenarios, we can truly then model the true usage patterns for our apps and our integrations, right? How often will it be run? How often will it be used per user, per tenant, per day, hour, or minute? Is it bursty in nature? Is it cyclical in nature? Or is it a steady flow of users or integration events, right? And from there, we can use that to really scope what needs to happen with our integration or our app. It's very easy for us to get lost in the nice to haves, but we want to remember what we need to do to get to a production ready state, right? Can any of that work be deferred to a separate stage or a follow-on phase two? Is the payoff of a nice to have feature really worth not only the design and development efforts, but the impact it's going to have to our architecture of either that app or that integration? And in a similar vein, we want to be smart about the happy path for our app or our integration, right? It's very easy to start finding all of these edge cases and these 1% scenarios that don't occur very often. And we need to think about those in the same frame of reference, right? What is the payoff for handling these edge case scenarios? Is it worth the investment that we're putting into this app, this integration from, again, a design, a development effort, and the trade-offs that it's going to introduce to our architectures? And all of this is kind of rounded out with assuming scale from day one, right? Thinking about the scale of these apps and these integrations from day one, not just today and what they're going to launch at, but what does it look like a month down the road, 6 months down the road, 2 years down the road, or even further? Planning for that ahead of time and rooting ourselves in the reality of what's really going to occur for our apps and our integrations when they're in production, actually being used out there in the real world. It's a foundational, simple best practice, right? But it's one to always remember and remind ourselves of, because it's very easy to get lost in those conversations when we're speaking to our stakeholders, talking about requirements, covering, the very nice to have features, right? And delivering the perfect solution from day one. And so grounding ourselves in that reality is always great to come back to. And it's good to remind ourselves of that now and then. With that, I'm going to hand it over to Merrick, who's going to talk to you about the something we learned and then kick us off into the developer program updates.
Okay, hello. I hope you can hear me. And now I'm going to do I need to do my usual thing. Wait, I'm going to grab myself here and now I can point. And so let's look at something we learned, because I think with the APIs, it's important to know that you have different APIs for the same thing. There's different approaches to the same thing. And for some APIs, like the ones that trigger specific Workday business processes, you can do that with a SOAP call. You can do it with a REST call. You can do it with an import SOAP call, which may have different security policies. So you implement this with a SOAP call one by one. Then you decide, no, import is going to be better for me because there's going to be less calls. Less calls, better, quicker. And then it doesn't work. and it doesn't work because there may be a security policy for that you need to enable. So keep in mind that there are security policies for different operations, and you may need to change them if you want to use a different operation for the same thing. So the same, but different at the same time. And for developer program updates, first, the usual DevCon plug. It's 1 month from now in a few days. See you in Vegas. If you haven't gotten your ticket yet, go get it. Here, there, up there. Register now. Scan the QR code and get in. Also, there's a digital pass for the ones of you who don't want to travel to Vegas where it's going to be very warm, but we'll have those transmissions too. And some updates that were released recently. WDCLI, you can grab your apps from the dev site. You can put your apps to the dev site. You can deploy, promote, do multiple different things. You can even integrate your usual continuous integration tools with our apps. You can even use the CLI to download them, put them on in Git or any other repository. I don't know, CVS guys out there, raise your hand or say something in the chat if you know what I'm speaking about. And for the other update is, come on, there we go, local disk sync. If you want to work on your local disk for an extend app or an integration app, you can store them directly on your computer, and then you can change them locally and push them out to the developer side, or you can download them from the developer side and make the changes manually. This would remove a lot of manual work for downloading and re-uploading. Again, reduce friction, use your CI/CD pipelines, and get everything done better and quicker. Orchestrate. Before we get to Orchestrate, I had to say something about integrations, and those may be different kinds of integrations. They don't have to be orchestration integrations. Those can be connectors, those can be EIBs, those can be studio integrations. And I've seen integrations that are meant to cater for scenarios where some data may be dripping into Workday during the day, during the night. And instead of doing something event-based, for any reason, someone decided, no, we need to run a connector every 5 minutes. And then you have a connector every 5 minutes, or you have a studio running every 5 minutes and checking, maybe there's a file on an SFTP. It takes the file, loads it to Workday. And then one of those data loads is bad, and the person in charge knows that it happened sometime between 1 and 2 p.m., so you have only 12 integration events to check. But if you know that it happened sometime last week, you can count how many integration events could have loaded that, and most of them are empty. If they are doing logging the proper way, then easy. If not, hard. Do you need to run those things every 5 minutes? I would say maybe not all of them. And so how to see what's your schedules? There's a task for that. That's called scheduled future processes. And when you look at scheduled future processes, in my tenant, there's going to be, for the process type of integration, there should be one thing, unless someone schedules something more. And that one thing is scheduled sometime in the future that would run every 5 minutes for 1 day. I don't want to make this tenant very unhappy with me, but if we look at the process, we know that it runs every 5 minutes starting at 12 and then for the whole day every 5 minutes. Does it need to run every 5 minutes? Maybe not. Maybe it should run every 5 minutes during the business hours, excluding lunch, and then it can run every hour during the night. Things happen in the night, but not that often. If you don't want to move it to a event-based, because it's a studio integration, and if there's 10,000 events, then probably that 5-minute schedule is better than launching 10,000 studios at any moment. But then outside of the business hours, when you don't expect a lot of traffic, you can have another schedule for the same integration. You can have those start times and end times, narrow it down 5 minutes from 9 to 11, then maybe from 11 to, I don't know, 1 p.m. every 15 minutes, and then from 1 p.m. to the end of the day, every 5 minutes, if that's the business need. Remember Dan's slide, what's nice to have and what's actually required. You may want to push back to the business user saying like, do you really need this every 5 minutes? Maybe they need, maybe they don't. Maybe you can figure out the best schedule or a combination of schedules for having that work best for everyone. So that's the integration plug. And now the orchestrate plug. For the orchestrate plug, we need to talk about my favorite thing, of course. So again, in the chat, anyone said join loop? Who said join loop? Did anyone say join loop? No. Okay, but we have CVS people. Good. So for data enrichment, there are some things that you shouldn't be doing, and I have this little button that says don't, and it doesn't work in Google Apps. But if I go to an orchestration, I can say don't do this, and I'll be scrolling here with the don't do this. So if you take a screenshot, don't do this. That's a screenshot of how not to do things. We have a very, very simple integration flow here that has a input CSV that's hard-coded here. Again, don't do this. That's simulating a file retrieved from somewhere, and it has the employee email and then the employee home email. And this one says many home, and for logan is going to be logan at many home local, and that would be for everyone. And because we have emails here and we aren't able to update the home email based on the business email, we need to figure out what the employee ID is. So we use WQL for that. We send the query, we get the employee ID, we create the SOAP payload. That's kind of boring. We have the SOAP payload here, and then we update the business email, and then we aggregate, store the results. Very basic, no error handling, or at least not a very sophisticated error handler, just a message if it didn't work. If we run that, so let's look for Madeline. For now, her email is at developer deep dive local. If we run the integration system that does all of those lookups, let's run this, and I hope it works. And what we are interested in here while this runs is the timing, because the timing is everything. So we are going to hit refresh, and we expect, based on the previous tries, that it's going to take about 1 minute for 100 updates. So I have 100 emails in that file. For each of them, we make a WQL call, we figure out the employee ID, and then we make the SOAP call. So we have 100 SOAP calls and 100 WQL calls. We are probably halfway done. So I'm just going to keep refreshing while this runs. And it's going to eventually complete, taking 1 minute of our life. Times, I don't know how many people, but not a very exciting minute, but I'm still going to keep refreshing. Probably mostly done, 59 seconds, 1 minute. But still no errors. From the fun facts, I didn't run this enough times to have the average time. I'm wondering if it's going to be faster every time I click. So if I click enough times, it's going to finish. There we go. 1 minute 29 seconds. We got a very basic output file with the XML results, but because we have only one message, it means the error handler didn't trigger, or the error handling integration message didn't trigger. So it works, and it works in 1 minute and 30 seconds for 100 people. You can do the math and estimate how long will it take if there were more. But as I said, join loop. So let's see how it would work with a join loop. I'm going to get rid of this. And then let's see in here that we have the thing with one lookup. And this one is slightly better. Don't do this either. That thing that's slightly better, it has different emails. So it's going to be at one home.local. And it's going to make one WQL call, fetch all the employees. So it's the same WQL call, just without the filter. I know I should be using a page call for this, but because I got the first 100 employees, that then they fit with this call that gets the first results. So that will work for my scenario, but it wouldn't work for your scenario. if you are going to use WQL to fetch all the employees, you should rethink the design because that's not great. Again, don't do this. But we have the join loop. Join loop is way better than what we had previously because right now we made one call for the employees. We do the pairing of the employees from the WQL call to the emails from the file in here. We create the API calls, and then we run them one by one. That should be quicker. And so let's check what's Madeline's email in here. This should have changed after our previous run. And this is now Madeline at many-home.local. So we run the integration that changes to the many at -home. And then we want to run the second one that does one lookup. Expectation is that this one is going to be quicker than 1 minute and 30 seconds. However, running something once is not a good way to measure performance. So let's see. There we go, 33 seconds, so it's 3 times faster. Good enough. So this worked 3 times faster, and now Madeline's email should be that she's at one-home-local. Sorry, one-home.local. So that's better, but still not great, not my favorite. And the reason why it's not my favorite is that this API call that we make here is change home contact information, and change home contact information has an import process. And of course, import process is the best. You can find a very similar example in the sampler. This is the same thing with the same mistake with the WQL, but otherwise this is the one that you should be doing. It does the same join loop. Then it does a batch loop in batches of 100. That's arbitrary. It can be batches of however many you can do in 1 hour. And then it triggers the integration that does the import. The integration that does the import is fairly boring because it just fetches the file that's shared with it, makes the API call to start the import, and then stores a file that we use later on in here to check the statuses of the import. So let's try doing this. We have the import, and let's run how it works. By the way, this should be way quicker. So it's now 5 seconds, 7 seconds. We have two files, 2 messages. So now it's doing nothing. I think I'm not fast enough, but if we go here and, sorry, here, orchestration activity, if I was fast enough, there we go, import home, email, I think it's already done. Yeah, it's complete. So I was not fast enough. If I was fast enough with this, we would see that the current status is sleeping, waiting, something that's not complete, while it was waiting for the other orchestration that was triggering the import to complete, which was fairly quick, and then for the import to complete, which was also fairly quick. So looking at this final thing with the import, it was done in 26 seconds, but so again, slightly faster than the time that we had with multiple API calls. But if we look at where we actually spent the time, then we spend the time pre-processing the data, so fetching the WQL, waiting, doing everything, 26 seconds. And then the import thing, it worked for 14 seconds. We can also check that in here if we look at the orchestration activity, which one is the latest, probably this one. So we can go and see that it works for 2 seconds. The rest of the time it was waiting. And then if we look at the other one, the one that triggered the import, it was also fairly quick because it didn't have much to do. Most of the time was spent waiting for the import to complete. So we have the import handler, and the import handler finished under a second. So those 3 steps, that was retrieving the file, starting the import and saying I'm done, and storing the file with the import ID, that has taken less than a second. So our original, our starting approach with making a lookup and a call for every employee in our file, or for every email in our file. If I had a bad email there, then we wouldn't find an employee. So making those requests, 1 minute and 30 seconds, so it's 90 something seconds of processing time, burned coal, sorry, not coal, we are green, so burned solar power, or water. I don't think we can burn water, but still, if it's water powered, I think it's green. But still, it's 90 seconds of processing time, generating heat, and working, while the last one was 2 seconds of work in the first orchestration, less than 1 second of work in the second orchestration, and we should have gotten a similar result where the email for Madeline has changed again, and now she's at import-home.local. I'm not sure if it's better that one home-local, but still it's a different email address. We have some files in here. For those of you who haven't seen the demo about the import processes, you can go to the forum and find it. We have a post for that. But what happened here, fairly quick, this was the file that we sent. There we go. So some XML with the import payload. Then when the import was started, this file was stored by the integration that we triggered. It only contains the WID of the import process, which the integration that triggered it can use in a API call to fetch the messages from that import process. And those messages come here in the import status report file, and there are no messages, which means the import was completely successful. We can double check if we don't trust it. We can take the WID, or we can take the ID here. That doesn't really matter. And if we search for that, we'll get the import process, and the import process is completed in 12 seconds, which means 2 seconds processing in the beginning, less than 1 second processing in the middle, and then 12 seconds processing here, which by my count is less than 15, which is kind of good. Way better than the 93 that we had originally. So it's quicker, greener, and generally better, just the same as the next speaker in our call.
All right, let me share my screen. So let's switch over to Extend. So as far as best practice, we should always be thinking about efficient endpoint usage with Extend, but when does it really, really matter? And so when it matters is when we're working with applications that have a large audience and and these apps are hit very frequent. For example, if you're building a back office app for 10 power users, a few extra API calls isn't going to have much of an impact. But if you're building a self-service app, small inefficiencies can decrease performance and increase your consumption. So what I want to talk about today are some quick wins that can be done to improve performance and drop down your consumption, endpoint consumption. Before I do that, in general, though, what you got to think about is when you're working with these high usage applications, is you just want to make sure that all of your endpoints that are being called have business value, and if they don't, then they should be on the chopping block. And so the first quick win here is pretty elementary and straightforward, but to remove unused endpoints. And the reason I bring this up is in my implementation days, I performed build reviews and code reviews. And one of the most common items that we found in those reviews were unused endpoints, endpoints that were defined but not referenced in the page code. And that could have happened because maybe the developer cloned it from a template, and then when they're in the refinement process, they took away that endpoint reference in the page logic, but left the endpoint definition in the endpoint list, or maybe cloning a page from another page. And so one just quick win that I want to call out is to make sure as part of your code review process that you go into App Builder and Extend, and you make sure that you run the validate function. So when you run the validate function, it will help identify any of the unused endpoints. And these unused endpoints that are still defined as endpoints um, would still take away from performance and take away and drive up consumption. So the next quick win that I want to talk about is I kind of want to talk about landing pages. So with an extend, we can build home cards that can be surfaced on the home landing page. And we can also build extend pages that can be embedded into dashboards and profile groups. Now, on these landing pages, if we're pulling in a lot of data with endpoints, it's possible based on the user's intent that they don't have the desire to interact with all of it, maybe just a portion of the app. And so that can lead to passive hits as far as endpoint calls and drive up consumption. So, for example, I'm going to go into my tenant, and here's my Workday landing page. And you can see here that I have two extend home cards. Um, this is for a peer recognition application. And so the use case is that that workers in the company get allotted a certain amount of points that they can award their peers, and they can give recognition to their peers and then also award points. And then these workers or employees can also redeem these points for rewards. And so we have two type of paths here: give recognition and redeem points. And you'll notice here that I'm pulling in via an endpoint the balance, right? How many points they have to reward, how many points they have to redeem. But think about this. Anytime a user logs into the tenant, maybe they're checking their payslip, maybe they're trying to update their timesheet, that though anytime they log in, even if they don't intend to interact with our app, these endpoints are going to trigger and it's going to drive up consumption. And so one thing to keep in mind is if that's not if that's that is one way you can drive down consumption is taking these endpoint calls and putting them further down in the experience when they have decided to go into the give recognition or the redeem points flow. That is when we could retrieve the balance, for example. So that's just one example of where you can um, re-architect to drive down your consumption. All right. So the next one that I want to talk about is worker photos and other images. So these can really drive up your consumption when used in at scale. So let me log into the tenant, and I'm going to proxy in as Peter. So Peter is a manager, and he's going to have a inbox item, and this is built in Extend. And this extend page is for the sales commission. So Peter is in here and he can look at all of his direct reports and their calculated commission, and he can come in here and make adjustments. Now you'll notice in here for each of his direct reports, we have a photo. So we have an API call to grab the header record of our for this page. And then based on that header record, we have another API call to pull in all these children records. Now, each of these photos, they also individually are taking an API call. So if you think about it, on page load, out of the seven calls, five of that is just based on cosmetics. So the question is, how much value are these photos adding to the experience? And if it's not providing a lot of business value, then that is something that could go on the chopping block to significantly reduce your consumption. Okay. So the last item that I wanted to talk about is the isCollection endpoint configuration. And so for large data sets, this can really cost as far as consumption and dramatically increase your API calls. So let me describe what isCollection is. So let me go to the tenant, and I'm going to pull up an extend page. Let's go to app preview. Okay, so this is an extend page where an admin can create a journal template. And then down here on this page, we have this shared with. So the admin can define, they can select workers who they want to share this template with. Now, if we go to the code, we have an API call, a REST API call, workers to populate our instance list. Now, this is a REST API call, and by default, an individual REST API call will only bring in the first 20 records. So if I go to the instance list and browse here, you'll notice that we have about 20 in here. Okay, but if I one there's a query parameter that we can add to the API to bump that up to 100, but we can't go beyond 100. So if I come in here, I can add limit equals 100, and let me refresh. And now you'll see that we have 100 records, but we don't have the entire population. Now, in this GMS tenant, we have about 470 workers. And so there is a configuration here called isCollection that you can turn on. And what happens when you do this is it's kind of like pagination. So essentially what happens is the framework will go ahead and for this API, it will go ahead and make multiple API calls until it's fetched the entire collection. And so for 497 workers, that's going to be 5 API calls. So let me go ahead and refresh. And now when I go to my instance list, we should have the complete population. But what I want to show you is if we go to the API logs, let's give it a second. Okay, so you should see these 5 individual API calls. Now imagine if your tenant had 50,000 workers, right? So with 50,000 workers, that's 500 or that's 5,000 calls, right? So probably it's not just a consumption issue. This is a performance issue. Your page is probably not going to run. And even if you only had 5,000 workers, right, and it was making 500 calls and by chance your page happens to load, I mean, that drives up your consumption. So we recommend not using the isCollection attribute for large data sets. So what can you do? So what you can do is convert this to a WQL that allows you to bring in more items, but even better, especially for like a worker search, is we can implement a search endpoint. So if I go down here to my instance list, I can configure a search endpoint attribute and I can assign it to one of my defined endpoints above. And then I also need to set up the attribute search result values. And this will take the response from the endpoint and based on the JSON path, point to the collection that we want to show in the result set. Now, if I go to my endpoint above here, here's our worker search endpoint, and we've marked it as deferred equals true. So what that means is when the page loads, this endpoint is not going to fire. It's only going to fire when the user is interacting with the widget and they entered in a parcel search. And then after they put in the partial search, what it's going to do is it's going to trigger this worker search. And if you can see in the URL here, this URL has a query string parameter search, which contains that partial text search from the user. And then what it will do is based on that, it will just bring back a subset of users that meet that criteria. So I'm going to go ahead and turn off the all workers endpoint that we were using originally. And I'm going to refresh this page. And then now when I go to that search, one thing you'll notice is we don't have anything. So we're not loading in that big, huge worker list. But if I come in here and do a partial search, let's do LO, you can see that my search endpoint is bringing back a subset based on that criteria. Then if I go to my API logs, let's give it a second to load. You can see that we have um, uh, an endpoint call for each time that I searched on demand. Okay, so these are some quick wins that you can utilize to kind of drive down consumption. Now I'm going to pass it to Todd, and he's going to talk about some other patterns.
All right. Thanks, Jared. Let me start sharing my screen. Okay. So I think I'm sharing my screen. I think we're good to go here. So I'm going to continue talking about deferred endpoints. And I want to say, we're going to talk about deferred endpoints, but with this conversation is about deferred endpoints and grids and making awareness to how when using them in a grid, you may be getting some excessive API usage in there. Deferred endpoints are extremely powerful. This is not an advertisement to not use deferred endpoints. Continue using them. They're great. They have a huge functional need. Performance reasons, keep using them. But be aware of when you're using them in grids, some impacts that they could have from an API usage point of view. The first topic we're going to cover three topics on deferred endpoints and grids. The first one is going to be an instance list. We're going to kind of continue following the discussion about the partial text search that Jared did there by the worker search by name. Then we're going to move on to a related value requirement. So this is where you invoke an endpoint on change for a given widget to populate a related value. So the example we're going to do is we select the cost center, and in the column to the right, you're going to display the cost center manager. And this third scenario we're going to talk about is a view-only grid, where we are going to be loading the grid from data that has already been persisted into our extend model object. And we also need to display the cost center manager there. So let's get started. For an instance list, we have a requirement. We're going to be building an app for a quick entry journal page. And it's going to be a journal entry page that must include a grid of journal lines. And each journal line must have a cost center instance list. The app has anticipated high usage, and as a result, we need to consider API usage when building and designing this. So the key consideration for this requirement is the cost center is at the line level of the journal. That means the cost center is going to need to be selected for each line, and there can be many, many lines for a single transaction. So we could get a lot of volume within the grid on that one particular widget. So let's take a look at this, and let's take a look at this with two different patterns here. We're going to start by our first pattern is just a straight deferred endpoint. So I'm going to come in here. And I'm not going to show the deferred code. Jared went through kind of how deferred endpoints work, so we got that covered. But within here, we hit the prompt. We have no results, so we have to put in a partial search, right? And we get a cost center. And now we got to do it again here. And we're going to get another cost center. But imagine, I mean, journals rarely have 2 lines, right? Usually there are 10 lines, 20 lines, sometimes thousands of lines where it's an integration and not an extend page or a page that could really be used for data entry. But just think about this, usually has a lot of volume. So every line that you go through here using a deferred endpoint, you're going to take that hit for an API call here, an API call here. If I add a couple additional lines, you're going to take that hit. So what other option do you have than using a deferred endpoint here? Well, you can load this data straight from onload. So you get the cost centers, you load that all initially, and you just keep reusing that endpoint. This is a pretty straightforward pattern. I think everyone is aware of this one. It's really just talking about bringing the awareness to using those deferreds within the grid and the volumes you have. Now, for small data, really easy, medium-sized data, you can do that in the grids. Sometimes you're going to be backed into a corner. And sometimes, like if we had to do your workforce and search by a worker, and you had to search by name within the grid, well, you can't load that all when the page renders. That's just too much volume. So in those scenarios, you might just have to take the hit or think about other ways to design the requirement so that way you're not taking the hit on each line. But ledger account, cost center, those are both things that reasonably could be loaded ahead of time. Okay. Moving on to our next example. Now we're going to talk about a requirement. Requirement, I see a question here, recommendation for preloading about 100 entries. I personally think it could be higher than that. I think it's going to depend a lot upon the impact that it has to load the page. So I used to think about like 30 to 50 would be what I would pre-populate with. But I feel like now, as long as it's not impacting your load time by multiple seconds, then I think it's fine to exceed that 100 lines. 10,000, no way, but somewhere in that middle lane, as long as your performance on loading the page doesn't take a huge hit, would be what you should be thinking about. Okay. Our next one is on change. So our requirement here is after selecting the cost center, we want the cost center's manager's name to be displayed in the column to the right. So we'll take a look at two options here. I believe this is my deferred, again, deferred. But here it's a little bit compounding issues with our deferreds. What we're doing here, actually, we're going to select the cost center first. Probably choose a reasonable number there. Okay. And then it hits another. So we got to do a search on the cost center, and then we're doing another search on the manager. So let's take a look at this from the code perspective. So come down to here to our widget cost center deferred. So we don't populate it with anything initially. And then we do our search endpoints. And then on change, when a value is selected, we're invoking an endpoint to go look up the cost center's manager's name to display in that column. So every time you are going to go through this grid and populate a line, you're taking 2 API hits for that. So you can see how that can quickly add up, and that could be just kind of a waste of usage. Now, what is the recommended pattern for this specific use case? Let's talk about that. We're going to come in here. Let's go through the code a little bit here. We're going to load the cost centers all initially. So here we go, not a deferred endpoint. And then within our onload script, we're going to come through and we're going to shape our data with our cost centers. Really, we're just doing a sort by description is what we're kind of doing here. We're also formatting it so we get the code and the name. So you got, cost center 3000 is human resources services. We're kind of building out exactly what that should look like. And then we're doing a sort by descriptor. But we're also doing something really key here. We're creating a map of our cost centers. One thing I didn't show you is let's take a look at our WQL and let's see what's there. So if we come up to our cost center endpoint that uses a query of cost center, come down here, we're doing the WID, the cost center number, the cost center name, and the cost center manager. So with this script here that we just did, where we do that on load, we are putting that entire result set, we're going to put into a map that we can reference later. So if we go to our widget, let me open up the page a little bit here. So our values, is going to be predefined on load. We're not hitting those again. And then on change, instead of invoking an endpoint or anything, we're hitting that map against the WID that we just selected, and we're returning that entry for it. Then in this next line, we're setting the cost center manager value to the descriptor for the cost center manager. So now in this scenario here, we can go through here. And we can go through all our cost center lines and not incur any additional API usage. So from here, doesn't matter how many lines we have in our journal, we had one hit against the cost center object to bring in data for both of these columns here. So we don't have that multiplier effect. So we're really just, one hit for everything that we have to do with cost centers. So that is a good way to handle, again, for small, medium-sized data within grids. Okay, next requirement we have is after our users create the journal, now it's going to route for approval. So what we want to do here is we want to load that cost center, and we want to load the cost center manager, and we want to do it as efficiently as possible. Well, our cost center is going to be stored within our extend model object that we persisted, right? That's the data we saved. That's the data that's getting approved. So we're just going to go retrieve that from our extend model object. But the cost center manager is not there, right? That's a related business object. So our two patterns here are one, which is really an anti-pattern for extend because it's going to be very slow. But in this anti-pattern, what we're doing is we're retrieving our journal line, our journal header, our journal line. We have a deferred point for our cost center manager. And we are hitting this every time a line is created when the page is rendering. It's going to go and invoke and do a lookup on each cost center individually to then display that manager name. So this is an anti-pattern because on load, it could really slow up and break your performance. We're going to see it. I put a little limit thing on here, so we're going to see it return with 20 entries. And a smaller number here, your customers, your users might not really see the performance impact on it. But when loading, we actually hit, don't know why. There we go. So we just hit an API call for each one of these. So this cost us 20 just for that, one for all the journal lines, and then one for the journal header. So that'd be 22 API calls to do this. But this could be done in a single API call, which is a related business object. So we're going to move on to our better practice, our best practice in this one. We got the journal line. We have the ability to use related objects using WQL. So we come over here, we have our cost center from our extend model object. We have the cost center instance, we have the cost center manager, and we can pull that value in all in a single API call, a single usage to populate the entire grid. And another call out on that is you can build calc fields on objects like cost center or the other things that your single instances. If you want to pull in those related values and they're available by a calc field, you can do that to reduce consumption. Sometimes there's a little bit of trade-off where you have to think about performance versus API usage. Cost Center Manager 1 in a GMS tenant is not one of those. But let's refresh this. And this one here will load fast because it's not hitting those excessive endpoints. And I actually have the journal lines is pretty high. We have almost 200 items out here. And you can see that it loaded about as fast as it possibly can, right? Just pulled all that data in, 2 endpoints, pages rendered. So this is a good way for view pages using related business objects, calc fields, things to pull those objects a level closer. Okay, next topic, moving off deferred endpoints, and now we're going to talk about flow variables. So flow variables are very powerful in multi-flow scenarios. So if you have a flow with page 1 that needs to pass some data to page 2, you can use a flow variable to do that versus requerying the tenant. So you can pass data from one page to the next page with these flow variables. So let's take a look at that in this specific requirement. So after we submit this journal entry, the user needs to be presented with a confirmation page. And that confirmation page should just say something nice like, hey, your changes were saved successfully. But it also needs to display the transaction that was just submitted and saved which includes all the journal lines. So there's two ways you can go about this. You could save, and then you could requery the tenant on the confirmation page and get those transactions. What I'm going to show you here is a way to do it without doing that. So on the create page, we're going to take a look at, we're going to try to give me some real estate here. Okay. So we have our outbound endpoints. We have the create journals and our journal lines. We do this in bulk, so we do it all in one request. And then we have our header. And then we're going to move down to our flow variables. And here is our journal header and journal line. These are the same endpoints, but now it's going to be the response from the endpoint that we're going to be passing forward to the next page in the flow. And then our flow, our confirmation page is right here. And what you're going to see here is there is no endpoint calls. There's nothing here that we hit the tenant to retrieve. Instead, we're just referencing our flow variables throughout here. So if we take a look here, flow variable header accounting date, flow variable ledger description, and same thing with our grid. We're doing our flow variable on the lines to iterate through and display all our lines. So if we come here and we create a journal, and I'm going to try to move faster. We're almost at time, and I think my session tenant's close to time and out. So we're going to see how fast I can get this in. Okay, we say okay here. Confirmation page, we have that, and we have our data that we just did. And there we go, we got our authentication issue. Sorry about that. But you saw how it just took the data from the create page, re-rendered it on the confirmation page without hitting the tenant again. So that wraps up flow variables and the value you use. Think about this anytime you have a multi-page flow. It doesn't have to be the confirmation page. That's just an easy example, but maybe it's a three-step process to get the data through. And maybe it's cost centers you look up on the first page. You can send that cost center object to the second page and reuse it there versus requerying the tenant. Okay, so that's flow variables, and that is our session. Thank you all for attending. And we will be posting this. I've seen the questions in the tenant. Yes, we will be posting this on the dev site. We will put the sample code out there as well. And just give us some time on that. Should be posted probably within 24 hours. And that's a wrap. Thanks, everyone.
Thank you all for joining us today.
Bye, everyone.